Okay, 14.3, we talked about dot product. 14.4 is vector product. Now, a vector product is similar to a dot product, except the dot product, remember, is a scalar product. So we just have magnitude. The cross product is the vector product. Now, with a vector, again, this is magnitude. So magnitude and direction. Okay, so it's magnitude and direction. Now we're going to be dealing with lots of vector products throughout this course, so it's a good idea to kind of learn how this works. Okay, so let's talk about the determinant. Determinant of order 2. Okay, and we'll do determinant of order 3 as well. But let's just talk about the determinant of order 2. So say we have some a sub 1, a sub 2, b sub 1, b sub 2, okay? And these lines represent a matrix. So the way this is going to work is we're going to multiply a sub 1 times b sub 2, so a sub 1 times b sub 2, and then we're going to subtract off b sub 1, a sub 2. B sub 1, a sub 2, or a sub 2, b sub 1. It really doesn't matter. Okay, so that's going to give you the determinant of order 2. Okay, the determinant of order 3 looks like this. We're going to have c sub 1, c sub 2, c sub 3. So it's always going to be in a line. Whatever variable we're talking about here, it's going to be the 1, 2, 3. And then we're going to have a sub 1, a sub 2, a sub 3. Then b sub 1, b sub 2, b sub 3. This is going to be written a little bit differently each time. At least if we're showing it in kind of the abstract form. But essentially, here's what's happening. We're going to first start with this c sub 1, okay? So we're going to have c sub 1, and we're going to multiply that times the matrix a sub 2, b sub 3. So we're going to multiply down this way. So a sub 2, a sub 3, b sub 2, b sub 3. So the way that works, remember, is we're going to multiply down, subtracting by multiplying up. Then we're going to subtract off this next term, c sub 2. Okay? And we're going to multiply that by the matrix a sub 1, a sub 3, b sub 1, b sub 3. So a sub 1, a sub 3, b sub 1, b sub 3. Again, this might look really confusing right now because this is the first time you've seen it, but after you see this a few times, this really isn't difficult. And then plus c sub 3. So we're going to do c sub 3. So we're going to use these two rows, which is a sub 1, a sub 2, b sub 1, b sub 2. And again, we're going to multiply by the determinants. So remember the determinant of order 2, remember, we're going to multiply down and then subtract off by multiplying up. So if I'm using this column here, c sub 1, I'm going to multiply by the determinant of these 4. If I'm looking at this column, c sub 2, I'm going to multiply by the determinant of these 2 columns. And then c sub 3, I'm going to multiply by these 2 columns, or the determinant of those columns. Okay, so let's actually see some of this in action. Okay. All right. So let's do just a basic determinant of order 2. So 1, 4, 3, 2. Okay, let's just look at that. Okay, so remember, we're going to multiply down. So we're going to have 1 times 2, and then we're going to subtract off that 4 times 3. Excuse me. So we have 2 minus 12, or negative 10. So the determinant here would be negative 10, okay? Now let's try a determinant of order 3. And I'm just going to write this as 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. All right. So remember, for this, we're going to start out with the 1 here, and we're going to multiply that by the determinant of these 4. So 5, 8, 6, 9. Then the next one, the middle row, we're going to subtract off 2 times our 4, 7, 6, 9. So 4, 7, 6, 9. Then we're going to add. So the first column, the third column are added. The second column is subtracted. So this is 3 times 4, 7, and then 6, 9. Okay, so let's do this math. So this is going to be 1 times my 5 times 9 minus 8 times 6. Okay, this is going to be 2 times 4 times 9 minus 7 times 6. And then plus 3 times 4 times 9 minus 7 times 6. Uh-oh, I made a mistake. Hold on. 2 was 4, 7, 6, 9. 3 was 4, 7, 5, 8. Sorry, that was supposed to be 5, 8. So 3 was 4, 7, 5, 8. 5, 8. My apologies. 4 times 8. 4 times 8 minus 7 times 5. Okay. And then doing this math, we end up with 45 minus 48, which is negative 3. And then I have, let's see, 36 minus 42. And that gives me what? Negative 6 times negative 2 is a positive 12. And then plus 4 times 8 is 32 minus 35. So 32 minus 35 is negative 3. Negative 3. Hold on, let me make sure I'm doing this right. 32 minus 35. And that's going to be multiplied by 3. 3 times, that's negative 3. So this should be plus a negative 9. Is that right? Okay. So this is negative 3, a negative 9 is a negative 12 plus 12 gives me 0. Okay. And that just happened to work out because we did 1, 2, 3, 4, 5, 6, 7, 8, 9. I could have chosen different numbers and done that as well. Okay. So again, whenever we have a column, okay, so let me change colors here. So this right here, when we're dealing with that column, we'll deal with these 2 columns. Okay. Okay. Then when we deal with this column, we're going to subtract off these 2 columns, the determinant. Okay. And then the last one, let's do purple. Okay. So when we deal with the purple, we're going to have this column times this column, the determinant of that. Okay. So Just remember, whichever number you start with here, you're going to hold the rest of that column. You're not going to use it. You're going to use the two opposite columns. So like with 2, we use the two opposite columns. And with 3, we use the two opposite columns. Okay? I hope that wasn't super confusing. All right. So let's talk about the vector product. So the vector product, remember, is the cross product. Okay? The vector product or cross product, you'll hear this referred to one way or the other way, okay? So this is vector product A cross vector B. So it's not a multiplication sign, it's a cross, okay? So this is of, let's see, my A vector, again, looks like A sub 1, A sub 2, A sub 3. And my B vector is B sub 1, B sub 2, B sub 3. Okay? So if this A cross B is going to look like this. Okay? So we have A sub 1, I'm sorry. Let me do this where this might make a little bit more sense. Let's do I hat, J hat, K hat, okay? Then we're going to have A sub 1 here, B sub 1, A sub 2, B sub 2, A sub 3, B sub 3. So the way this would work out is we have our I hat times our A sub 2, B sub 2, A sub 3, B sub 3. And then minus, remember the second column is always minus, J hat, A sub 1, B sub 1, A sub 3, B sub 3. So this is A sub 1, B sub 1, A sub 3, B sub 3. And then plus K hat. And that's our A sub 1, B sub 1, A sub 2, B sub 2. So this is A sub 1, B sub 1, A sub 2, B sub 2. Okay? So that is our notation for this. So let's do an example of this. Say our, let's do A cross B, okay? And we're going to say if our A is equal to 1, 5, 7, and our B is equal to -2, 3, 4. Okay, so let's have that. So we have I hat, J hat, K hat, and my A is 1, 5, 7, and my B is -2, 3, 4. All right, so we have I hat. Now you could put the I hat over here or out front. I'm just doing it out front for these first few problems. Usually I do it afterward. So this is going to be 5, 3, 7, 4, and then minus J hat, which is 1, -2, 7, 4, plus K hat, and this is going to be 1, -2, 5, 3. 1, -2, 5, 3. Okay? So this gives me, doing the math, I end up with 5 times 4, which is 20, minus 20 minus 21, and that's I hat, minus 1 times 4 is 4, 7 times -2 is -14, and that's J hat, plus 1 times 3 is 3, minus -2 times 5 is -10, and that's K hat. So this gives me one I hat or negative I hat. 4 minus 14 is negative 10 times a negative. I'm sorry, 4 minus 14 is negative 10, and it's positive 10 j hat. 3 minus a negative is positive. 3 plus 10 is 13 k hat. Okay. All right. And then, so this would be our answer, negative I hat plus 10 j hat plus 13 k hat. That's if we do the cross product or the vector product of A cross B, where A is 157 and B is negative 2, 3, 4. Okay. All right. And then there's a theorem. So your first theorem in this section is the vector product. The vector product or the vector A cross B is orthogonal. Orthogonal, you may have never heard that term before, to both vector A and vector B. Now, what does orthogonal mean? Well, orthogonal is just a nice way of saying perpendicular. Okay, it's perpendicular. So the vector product of A cross B is perpendicular to both your A vector and your B vector. So if you were to do a three-dimensional of your A vector and your B vector, so let's go back to this one. If I were to draw out this vector, 157, so that's my X is 1, my Y is 5, my Z is 7, so that three-dimensional. And then for my vector B, negative 2 is X, 3 is Y, 4 is Z. Then the cross product will be perpendicular to this vector, and it will also be perpendicular to that vector, okay, individually. All right, and here's the corollary. And the corollary is two vectors, A and B, are parallel if and only if and only if, and you'll sometimes see this written as IFF, if and only if vector A cross vector B is equal to 0. So what that's saying is, if these vectors are parallel, that can only happen if the cross product is equal to 0. Okay. Now, please do page 717, 1 through 14. Sorry about that.